In this video, we are going to discuss about definition of array, declaration of array, initialization, accessing, memory representation, and how to read and display the array elements, and finally the operations on arrays. Here, the definition of array is defined as a collection of similar data type elements and all the elements are stored in adjacent memory locations. Here, arrays we are mainly used to overcome the ordinary variables. Why? Because ordinary variables means it stores at a time only one value. For example, let us a equals to 10, a equals to 20. At a time we can store only one value, but in the array we can store multiple values with similar data type elements. Now let us see syntax for declaring an array. Data type space followed by array name within the square bracket, size ends with the semicolon. Here the possible data types are int, float, char, and coming to array name, we know the rules of identifiers. For array name we have to follow the rules of identifiers. Now let us take one example. Int a of 10 means here the size of array is 10. For arrays, the array index starts from 0th location to size minus 1. Means here the size of the array is 10. So 0 to size minus 1 means 0 to 9. For accessing, we start array index the elements from a of 0 to a of 9. So this is about how to declare an array. Then now we are going to discuss about how to initialize an array. Initialization of array can be performed in two ways: compile time initialization and runtime initialization. Runtime initialization means we have to give the elements in the console, but in compile time initialization we have to initialize the array elements within the code. So now let us see for compile time initialization. Compile time initialization, here we know the syntax of array: int variable name within the square brackets array size equals to flower braces. Here we are using flower braces to initialize the array elements. Here we give some elements. For more than one element we use comma by separating the values and ends with the semicolon. For compile time initialization, here size is not mandatory. I mean, if we give the elements means we are giving 5 elements, so the compiler will declare the size by calculating how many elements we are giving. That is initialization. Now we see about memory representation of array. Let us take above example. Let we are using 32-bit compiler, then the size of the integer is 2 bytes. Then total here want 5 elements, so 5 into 2 10. 10 bytes of memory is allocated to this array. So let us 10 bytes, here is the representation of memory allocation. Yeah, for this first element 10, 1001 is for 10, 1002 1003 is for 20, like that. Here it's like a continuous memory allocation. We know that the definition of array. What is the definition of array? Array is defined as collection of similar data type elements and all the elements are stored in adjacent memory locations. Here the data type is int. All the elements are stored in adjacent memory location with similar data type means int. That is the memory representation. Here array follows a continuous memory allocation. Here we see how the memory is allocated to array elements. Now we see how to access an array elements. Here the syntax to access an array elements is array name for within the square brackets index. We have to specify the index of an element. For example, if you want to access the first element of an array, we use a of 0. If you want to access the second element of array, we use a of 1. Like that we follow that one. If you want to access 20th element of an array, then its index is 19. So A of 19. Now let us see how to read and display the array elements. Here this is the logic for displaying an array elements. Here we are declaring an array, and for iteration purpose we using one variable I and n for size. Here printf enter the size of an array, scanf percentage %d and ampersand n. Here size of the array is 5. Then printf elements of array, enter the elements of array, means here this message is displayed in the console. For I equals to 0, I less than n, I plus plus, scanf percentage %d ampersand a of I. Here why we are using for loop, means for more than one element we are using for loop. Here we are taking 5 as an array size. First here I equals to 0, I less than n means 0 less than 5, condition is true. Scanf percentage %d comma ampersand a of I. A of I means a of 0, here the first element. Here the 10 will be stored in the 1000 memory location. Then I plus plus 0, 0 becomes 1, 1 less than 5, condition is true. Then a of 1, 20 will be stored in 1002 location. Likewise up to 50 means 4 less than 5, condition is true, 50 is stored in 1008 location. Then I plus plus, I becomes 5, 5 less than 5, condition is false, then it will come out of the loop. Then printf elements in the array are, for more than one element we are using for loop only. For I equals to 0, I less than n, I plus plus. Here I equals to 0, 0 less than 5, condition is true. Printf percentage %d commas /t a of I. A of 0 means 10. 10 will be displayed here. Then /t. /t means we are giving some three tab spaces. Then I plus plus 1, 1 less than 5, condition is true. A of 1, 20, 20 will be displayed here. Then tab space. Likewise 4 less than 5, 50 will be printed like that, 10, 20, 30, 40, 50. Here finally I plus plus 5 less than 5, condition is false, and the execution is over. From finally in the console, here print is 10, 20, 30, 40, 50. This is the logic for displaying an array element. Now let us see an operation of an array. Insert an element into the array at begin position. So we have to insert an element into 0th location. Begin position means first position, 0th location. For this we have taken the array size is 5. We have to insert an element 100 into 0th location of an given array. For this we have to take 10, 20, 30, 40, 50 for array elements. For this a of 0 equals to 10, a of 1 20, a of 2 30, a of 3 40, a of 4 50. What our main purpose is to insert an element in 0th location. That means we have to insert the 100 at a of 0. For this 50 is moved to a of 5. I mean here the array index is from 0 to size minus 1, means a of 4. But we have adding one more element, so we have to increase the size, means n plus plus, means we have to declare an variable for size n equals to 5. For this we have to increase the size n plus plus, means a of 4 means we have increased one more, means a of 5. That 50 element, last element is moved to a of 5, 40 means a of 4, 30 a of 3, 20 a of 2, 10 a of 1, and at last we have to insert an element 100. So in this 0th location we have to insert an 100 element. Okay, let us see with the code. Header files, main function for declaring an array, and for iteration purpose loop I, and for size a n, and we have to insert an element, means we have to declare one variable name. Printf enter the size of an array, and scanf percentage %d ampersand n. Printf enter the array elements. This message will displayed in the console. For more than one element we have to use for loop. For I equals to 0, I less than n, I plus plus means what is n? N equals to 5, 0 less than 5, scanf percentage d a of I, a of 0 10, like that. I plus plus means up to 50 element it will be stored. Then we have to insert one element at begin position, means printf enter element to be inserted and we have to read that value element. For example, we have to enter 100th element at 0 location. After reading the element, it means we have to increase the size of an array, so size will be incremented n plus plus, so n will become 6. Now we have to store, means we have to swap the elements from one location, so beside location, means for I equals to n, n means size of the array, n equals to 6, I equals to 6, I greater than 1, I minus minus. Here what the logic is, a of I minus 1 equals to a of I minus 2, means now here the 50th element, 50 element is in 4th location, we have to move that location to next location, means 4th location to 5th location. Here total size is 6, 6 minus 1, a of 5 equals to a of 4. Okay, what is a of 4? A of 4 means 50. This 50 element will be moved to a of 5, like that. Here if next n equals to 6 over, here next n minus minus, n equals to 5, a of 5 minus 1 means a of 4 equals to a of 5 minus 2, a of 3, a of 3 means 40, this 40 will be stored in a of 4, like that up to 1, a of 1 equals to a of 0, that means here a of 0 is 10, it will be stored in a of 10. At last loop will be, loop exited, then a of 0 equals to element. Finally what our main target is to insert the 100th element at 0 location, that will be inserted here. Printf after insertion array elements are, for iteration purpose and display we use for loop and we have to print like this. At last the output is 100, 10, 20, 30, 40, 50. This is the logic for inserting an element into the array at begin position. Insert an array element at begin position means we have to delete the 0th location element, means for example we take 10, 20, 30, 40, 50, means we have to delete 0th location element, means 10th element we have to delete. For that we have did some operations. We have taken n equals to 5, means size of the array is 5. For deleting an element from an array is very simple, its logic is very simple. After deleting 10th element, the next element 20 will become the 0th location, 30th will become the first location. We have to move this element to 0th location, means 20 will be stored in 0th location, 30 will be stored in first location, like that 50 will be loaded in third location. It means after deleting the first element the size will decrease, means the size of an array will become 4. Okay, let us go through with the one's code. Here header file main function, for declaring an array and for iterating purpose we have taken some variables. Printf size of an array, scanf percentage d and ampersand n. Here we are giving the size of an array is 5, it will read, and printf enter array elements, it will display on the console. For more than one element we use for loop, for I equals to 0, I less than n, I plus plus. Here the size of an array is 5, so for condition 0 less than 5, condition is true. Scanf percentage d ampersand a of I, means a of I means 0th location. At 0th location the element 10 will be stored, like that 50, 10, 20, 30, 40, 50 will be stored at 4th location. After enter the elements the size will be decremented. Why? Because we have to delete the element from an array. So array size will be decremented. N minus minus means n equals to 4. Now for I equals to 0, I less than n, I plus plus. For now we have to move the location, first location element into 0. I mean first location, I mean 0th location. This 20 will be moved to the 0th location. Then automatically 10 will be erased. For this logic, a of I is equals to a of I plus 1. So now first I equals to 0, a of 0 equals to a of I plus 1, a of 1 means the a of 1 value will be stored in a of 0. That means this 20 will be stored in a of 0. Okay, next a of 1, a of 1 equals to a of 1 plus 1, that is a of 1 equals to a of 2. A of 1, a of 2 means 30, 30 will be stored in a of 1. Likewise I plus plus a of 3, a of 3 equals to a of 3 plus 1 means a of 4, means a of 4 means 50, 50 will be stored in a of 3. Next I plus plus 3 becomes 4, 4 less than 4. Why? Because the array size is 4, 4 less than 4, condition is false, it will terminate the loop and come out of the loop. Printf, after deleting array elements are, for more than one element we know for loop is used. I equals to 0, I less than n, I plus plus. 0 less than 4, because why? Because array size is 4, 0 less than 4, printf percentage d slash d a of I. A of 0 means, here a of 0 means 20, 20 will be printed. Next space I plus plus 1, I becomes 1, 1 less than 4, a of 1, a of 1 means 30, 30 will be printed, space 40, space 50. This is the output. Yeah, this is all about arrays, array definition, declaration, array initialization, array accessing, memory representation, and finally array operations. Yeah, thank you. I hope all are understand this video. Thank you so much.